All right, so now we are figuring out the equivalent resistance of the circuit and the voltage across each resistor and the current through each resistor. I should qualify this with the caveat that this is more involved than your test question will be. There is an equivalent resistance question on your test, but I would never ask for all of these things. I might ask for one or two of them and if I were asked for two of them, I'd ask it in two separate multiple choice questions. So don't think that you're going to be spending 8 hours on your test trying to do a problem like this. Okay, so equivalent resistance of the circuit. I think a quick way to get messed up in this is to make the mistake that all three of these resistors are in parallel, because they are not. These two resistors are in parallel with each other because they can both be traced back to a common junction, right? That goes to there, that goes to there, that goes to there, that goes to there. This one does trace back to that junction on the top, but on the bottom, there's a battery in the way. So there is no resistance-free path between the bottom of this resistor and that same junction. So this one, you can't just eliminate all three of these down to one in one step. You got to do it in two steps. So these two are in parallel, and I'll get rid of them first. So I have, I'll call that R1, R2, and R3. So get rid of R1 and 2. R1, 2 will be two in series, in parallel with each other. So that's 1 over 750 plus 1 over 680 to the negative 1. And I got that to be 356.7. So our second circuit will look like this. So there's our 12-volt battery and R3 and R1, 2. Now these two are in series with each other, so we can combine them to get the equivalent resistance to be 356.7 plus 990, which is 1346.7 ohms. With sig figs here, I think actually the technically appropriate thing to do is to round it to the tens place. So that'd be 1350. But in lecture, these three numbers have two sig figs. So if you rounded that down to 1300, down to two sig figs, that'd be fine too. That would be fine. And of course on the test it would be multiple choice, so that would probably not be a question. Okay, so next is the voltage across each resistor. And here we start to get a little harder. So to figure out the voltage through each resistor, we first need to figure out the current supplied by the battery. So let's figure out the current coming out of the battery. So we have that I battery is going to be the EMF of the battery divided by the equivalent resistance of the circuit. So that's 12 volts divided by, and now I'll make sure that I keep a few extra sig figs, especially with multiple choice questions here. You're going to get quite a bit of sort of rounding difference if you use 1350 or 1300. So I'm just going to use the full number, and then I'll worry about rounding at the end. So I'll do 1347 ohms. And I get 0.008909 amps. So 8.9 milliamps. All right, so now we know how much current is coming out of the battery, which means that we also know in this circuit here that that's a series circuit. So there's the same current coming out of the battery as there is in this equivalent resistor and also as there is in R3. So we can figure out the current through R3 because we already know what it is. So that's I3, which is actually something we don't need until C, but we may as well. We got it. We know it. If we know R3 and I3, then we also know V3. So we can figure out V3 is just going to be I3 times R3. So that is this 8.9 milliamps times 990 ohms. And I got that to be 8.82. So that's 8.8 volts. Okay. So now we have stuff on the third resistor, and we know that the current going through both of the resistors must add to that. We don't actually know the current through individual resistors, nor do we know the voltage drop through individual resistors. But we do know that the voltage drop across this and across that are the same. So we know that these two have the same voltage drop, and namely, it's whatever that voltage drop is. So I think probably the easiest way to look at this is to do a loop rule. So we know that we have 12 volts here, and we're going down 8.8 volts here, and that leaves us with whatever 12 minus 8.8 is. And in my calculator, that's what that ended up being. So I know that delta V1 equals the voltage drop across V2, which equals the voltage drop across that equivalent resistor, which is 3.2 volts. So there is our three voltages. And we have one of our three currents, but not the third. So let's do the current through these two. So we know that we have 8.9 milliamps in here, so 0.008909 amps, and that's going to fork into the two of them. So you could do some kind of fancy math to figure out exactly what these things are, or you could recognize that you already know the voltage drop across that resistor. You already know that it's resistance, so you can just use Ohm's law to figure out that current. So let's do that. So if I want to figure out I1 is going to be the voltage drop across 1 divided by the resistance of 1. So that is the 3.2, so 3.18 volts divided by 750 ohms. So if I do that, divided by 750, I get 0.00424 amps. I'll round that to 2 sig figs, so 0.0042 amps. For I2, we'll do the same thing. So that's going to be V2 over R2. So that'll be 3.18 divided by 680. And that is 0.00468 amps, which is 0.0047 amps. So there's I1, and there's I2, and we already figured out I3. Just as a check on your work, it's definitely useful here to look at the junction rule and make sure that you're getting the right answer. So I better have that the current into the junction equals the current out of the junction. So I better have that this equals that plus that. So if I do 0.0042 plus 0.0047, those two numbers added together equal 0.0089. So I've verified the junction rule works independently of my work. So I feel good about my answers.